Hi, welcome to today's mathematics tutorial. Today we're going to look at indices. What is indices? Indices simply means a method of shortening the product of two or more equal factors. Example, I have a times a times a times a, which is here equal to what we're considering is number of times that a appeared, and here a appeared 4 times, that is a raised to power 4, where a serves as the base and 4 serves as the power or the index. Now this is just the method of writing numbers or equal factors in index form. And let's go down with this particular example. If I have examples such as 1, write the following in index write the following in index form. What will they give to us? We have it as a, which is 2 times 2 times 2 times 2 times 2 times 2. Then b, 3 times 3 times a times a times b times b. Solution. Now how do I write these particular examples in index form? What we are considering here is equal factors. So from the example a, here we have it as example a, we have it as 2 times 2 times 2 times 2 times 2 times 2, 2 times 2 times 2 times 2 times 2 times 2, which is equal to, here 2 appeared how many times? 1, 2, 3, 4, 5, 6. That is 2 raised to power 6. That is in index form. Just pick one of the base and then count the number of times that the equal factors appear. Then you get your result in index form. Then we go down to example B. Example B, here we have unequal factors. Definitely here we give us 3 times 3 times A times A times B times B. So how are we going to get this particular result? We ask yourself, how many times did 3 appeared? 3 appeared twice, A appeared twice, and B appeared twice. So definitely here will be 3 times 3, that will be equal to 3 raised to power 2 times A appeared 2 times, that is A raised to power 2 times B appeared 2 times B raised to power 2. So this serves as the answer because there is no other equal factors here. And this will lead us to what we call the laws of indices. Now, the laws of indices are 8 in number, and we're going to look at the 8 laws, one after the other. We have the first law, which is the multiplication law, says A times X times A times Y, which is equal to, whenever two equal bases that are raised to power is being multiplied, what happens to their powers? Their powers are being added together. That is A raised to power X plus Y. We go down to the second law, that is opposite of the first law, A raised to power X divided by A raised to power Y. Here the bases are equal. So whenever two equal bases are being divided, the power of the divisor is subtracted from the power of the dividend. So that will be equal to A raised to power X minus Y. We subtract the powers because the bases are equal. Now let's go down to the third law, A raised to power 0. Anything raised to power 0 is equal to 1, except anything raised to power 0 is equal to 1, except 0 raised to power 0, which is not equal to 1. Why? Because it is undefined. Then we go down to the fourth law. What does the fourth law say? The fourth law is the negative index. We have anything raised to power negative, anything raised to negative power is equal to the reciprocal of that particular base, then raised to positive power. So that will give us 1 divided by A raised to power 1. And here will be 1 divided by A raised to power 1 will still give us A. Then we go down to the next law, which is the fifth law, the root law. What does the law say? The root law is the law that shows different root. Half A raised to power half simply means the square root of A. Then A raised to power 1/3 will give us the cube root of A. That is the cube root of A and the square root of A. So it's the law that shows different roots. Then we go down to the next law, which we call the product power law. The product power law, which is number 6, the product power law, we have A, B raised to power X. Because the base here are unequal, what are we going to do? Just share the power among the unequal base, that is A raised to power X, then times B raised to power X. That is all about the product power law. Then we go down to the seventh law, which is the power law. What does the power law say? The power law here, we have it as A raised to power X, then in brackets A raised to power. Whenever a number, a base is being raised to power and again raised to another power, what are you going to do? What you have to do is just multiply the powers, that is X and Y, that is X times Y. X times Y. We go down to the eighth law, which is the fractional index. Fractional index. In this case, what you're going to find is the root of y, that is the root of y here, y root of a, and raised to power x, which is the numerator. So these are the 8 laws of indices. We are going to solve example using the laws of indices here. Let's just take down these examples of example 1. Let's take down example 1 here. Example 1 here says write down the value of the following. Write down the value of the following. A here give us 32 raised to power minus 2 over 5. 32. Then we have B. The B part of it gave us 121 all over 169. 121 all over 169 raised to power minus half. So how do we solve this particular question and get our result done? How do we get this and get the result done? And let's take down the solution here. From here, the solution, we have the first question under solution A. The question says 32 raised to power minus 2 over 5. 32 raised to power minus 2 over 5. So definitely we have 2 laws here, but first you have to obey the first law, which is the negative index. And the negative index says whenever a number is raised to negative power, use the reciprocal, then raised to positive power. The reciprocal of 32 is just the inverse of 32, which is 1 all over 32, then raised to power 2 over 5. Then the denominator here gave rise to what we call the fractional index. In this fractional index, you look for the root of the denominator. The root of the denominator, so that should be 50 root of 32 raised to power 2. And that will be equal to, we look for the root, give us 1 over, we have it as 1 over the 50 root of 32, that is 50 root, or just solve 1 divided by the 50 root of 32, then raised to power 2. And what will it give to you? That will be equal to 1, the denominator, all over. The 50 root of 32 will give you 2. That is a number that can multiply itself into 5 times to give you 32, that is 2. We have it as 2 raised to power 2, and that will be equal to 1 all over. 2 raised to power 2 here will give us 4. That's the answer. Then we go down to the second part of the question. What will it give to you in the second part of the question? We have it as the 121 all over 169 raised to power minus half. So definitely we equally have 2 laws there. We obey the first law, which is the negative index, and that will be equal to, according to negative index, you use the reciprocal of 121 divided by 169. The reciprocal of this number is obtained by changing the position of numerator and denominator, and that will give us 169 all over 121. So we have eliminated the negative power. What we have here is just the half. And remember that this law is the root law that shows variable roots. So anything raised to power half here is the square root. So we go down, look for the square root of the given number. Square root of 169 over 121. The square root of 169 is 13. The square root of 121 here is 11. So 11 cancel itself. 1 cancel 13 will be equal to 1 1 remainder 2 all over 11. So this is the result, the answer of the question 2, example 2 here, which we have here. And let's take down the second example. In example 2, the question says, what you have a question like this that says, solve or find, we go down, find the value of n. Find the value of n. We have a, which is 4 raised to power n plus 1 is equal to 1. Then B, 49n is equal to 7 raised to power n all over 343. Solution. How do we find the value of n here? In this case, we have equation, indical equation. So under solution, what are you going to do? What you're going to do is make sure that you express the two sides, the two bases to be equal. Ensure that the two bases are equal before you simplify further. So under solution, we go down with the first one. A, which is 4 raised to power n plus 1 is equal to 1. So what's the least base of 4? The least base of 4 here is 2, or if you like, you can equally go with what you have here, 4 raised to power n plus 1 is equal to 1. According to 0 index, anything raised to power 0 will give us 1. So definitely we should be mindful of this particular one here, and that will be what will give us this one. That's 4 raised to power 0 will still give you 1. So what we're going to do is just exchange the position. You substitute that will be 4 raised to power n plus 1. 4 raised to power n plus 1, that will be equal to 4 raised to power 0. So because the bases are equal, you can easily cancel out the base and then you equate the power. So here should be cancel out the base and equate the power. If you equate the power, what are you going to have? Equate the power, so that will be n plus 1 is equal to 0. Therefore, you make n the subject of the formula, so n is equal to when plus 1 crosses the equality sign, changes to minus 1. So n here is equal to minus 1. We go down to the second example, with example B part of it, which is 49 raised to power n is equal to 7 raised to power n all over 343. What will it give to you? Express both sides to be on equal factor. So the least factor here is 7. We have it as 7 raised to power what to give us 49, 7 raised to power 2, then power n is equal to 7 raised to power n. 7 raised to power what to give us 343, that is 7 raised to power 3 will give us 343. So definitely what we have here, you open the bracket, and this law will give us what you call the power law, whereby you multiply the powers. So have it as 7 raised to power 2 times n will give you 2n is equal to, you obey the division law here, because the bases are equal, the power should be subtracted. 7 raised to power n minus the power of the denominator, which is 3. So you cancel out the equal base and then you equate the power as well. Equate the power. If you equate the power here, what are you going to have? You have it as 2n is equal to n minus 1. So you collect the like terms. Collect the like terms. Here 2n, here is n. When n crosses, changes to minus n. So we have it as 2n minus n is equal to minus 1 remaining. Or you subtract n from both sides. 2n minus 1n will give us n, which is equal to minus 1. So n here is minus 1 and n here is equal to minus 1 equally. So I'm going to stop here for now. In 2 days time, we're going to discuss about the advanced level of indices. So for you to be a part of the class, just click on the subscribe button. Thank you and see you by this time, 2 days time.